Today, we are going to look at how to tackle these free response questions on your Calc exams. Now, this question was taken directly from the 2019 AP Calc AB/BC exam, the free response portion, obviously. If you'd like to know where I got this question, where you can find other questions like it and their answers, just Google AP Calculus BC/AB free response questions 2019. That's what this year is from. And then when you search for that, the first result you find should take you to College Board's website, and you'll see tons of years where you can look at questions and answers. Now, with that out of the way, let's look at my thought process as I answer these questions. So hopefully you can pick up the skill of translating the questions and applying it to your own exams. So, our question. The continuous function f is defined on that interval. The figure above shows a portion of the graph of f consists of two lines and a quarter circle centered at the point 5, 3. Okay, I wonder if that's important. It is known that the point 3, 3 minus the square root of 5 is on the graph of f. All right, that's probably going to be important too, but we'll remember that for later. Let's look at part A. So, if the integral from -6 to 5 is equal to 7, find the value of the integral from -6 to -2. Show the work that leads to your answer. Okay. Now, remember how I briefly said translating these problems was like a skill you need to have? What is this asking us? Well, when I read this, I see, okay, the area under the entire curve, so from -6 to 5 is equal to 7. And we want to find the area underneath the curve that we can't see. What do I mean we can't see? Well, they give us from -2 to 5, right? We can see that. What they don't give us is from -2, well, from -6 to -2. That's what we're going to try to find. So how do we do that, right? Well, if they give us the entire area underneath the graph and a portion of the graph, then maybe if we subtract the portion we're given from the total area, we can find the other part that we're looking for, right? That makes sense algebraically. So if we do 7 minus whatever the area from under the curve from -2 to 5 is, we should get our answer, right? Makes sense. So how do we find the area underneath the curve? Well, luckily for us, the area underneath the curve is given to us by a ton of shapes, which we can find the areas of easily. And then if we combine those areas, we'll find our area underneath the curve. So let's do that. Right here, let's use orange. We have two triangles that are the same, but they're on opposite sides of the y-axis, so the areas will cancel each other out. Great, we have an area of 0. We have the same thing going on over here. They're different size triangles than the other ones, but they're the same to each other, so they cancel each other out. Phenomenal. Uh-oh, we have a weird area. We have whatever this is. This is not a shape we learned in geometry. Oh boy, how are we going to find the area of that? Well, I'm thinking I could see a giant rectangle around this, right? Rectangles are easy. This is a 3 by 4 rectangle, so its area is going to be 12. And underneath that rectangle, we have our weird shape, a triangle, and a quarter circle. So if we subtract the quarter and the triangle from our rectangle, we should get our weird area, right? That makes sense. So if our rectangle is area 12, and our triangle, right, it's a 2 by 1 triangle, so the area of that is going to be equal to 1, so let's subtract that. And the area of our quarter circle is 1/4 pi r squared, and its radius is 3, so that's going to be 9 pi over 4. We're going to get that the area of our weird shape is equal to 11 minus 9 pi over 4. Wow, that was so easy, but we're not done yet. We still have to subtract that from 7. So 7 minus 11 minus 9 pi over 4. And what does that get us? Well, this is simple subtraction. This is too easy, right? This is going to be equal to 9 pi over 4. 7 minus 11 is minus 4. That is our answer for part A. Look at that. 4 minutes in, and we did a part of a question. Good job on us. Okay, let's go to part B. Evaluate the integral from 3 to 5 of 2 f prime of x plus 4 dx. All right, we're going to need a little bit more space, so we're going to swap to another screen for this. So integral from 3 to 5 of 2 f prime of x plus 4 dx. Now we can make this simpler by splitting this into two integrals and pulling the constant out in front of one of our integrals. So we have 2 times the integral of f prime of x dx from 3 to 5 plus the integral from 3 to 5 of 4 dx. Now I say we evaluate this right side integral first because that's an easy one. The integral of 4 is equal to 4x. So we evaluate this from 5 to 3, we get 4 times 5 minus 4 times 3. That is 20 minus 12, right? So that's going to be equal to 8. And then we got to add the integral of our left side. So integral of f prime of x. Now the integral of a derivative is just going to be the original function, right? That makes sense. So we're actually looking for 2 times f of x evaluated at 5 and 3. Now how are we going to know what f of 5 and f of 3 are? Well, let's go and look at our graph for those. Okay, here we are at f of 5. Let's use green. So at f of 5, we're at 0, all right? And at f of 3, we are at this spot, and oh, that doesn't look like a whole number. Okay, well, I guess this is the point where we just give up and skip to the next question. Wrong. If we look back at our question, right? Look at that. They gave us what f of 3 is equal to. It's 3 minus square root of 5. Always check your questions for the information they give you because it's usually there for a reason. So f of 3 is going to be equal to 3 minus the square root of 5. So let's see. Let's go back to our purple. We have 2 times f of 5 is going to be equal to 0. And then we're going to subtract 3 minus the square root of 5 because that was our f of 3. So this becomes 2 times, what does this become? 2 times the square root of 5 minus 3. And then this is going to equal to, we're going to distribute our 2. So we get 2 times the square root of 5 minus 6 plus 8. And our final answer is equal to 2 plus 2 times the square root of 5. Wow. Look at how we did that seemingly difficult question. 2 minus 2 times the square root of 5 is our answer. Okay, we are halfway through this question. Let's look at part C. Function g. Oh boy, why are they giving us another function? The function g is given by g of x is equal to the integral from -2 to x of f of t dt. Find the absolute maximum value of g on the interval. Okay, so this whole translating thing that I mentioned is a skill that you will pick up as you practice these free response questions. What do I mean by translating? Okay, well, when I see find the absolute maximum value of g, I interpret that as take the derivative of g and set it equal to 0. And so that's exactly what we're going to do. So g of x here, let's write what g of x is equal to, and let's clear this right now. Clear. So g of x is equal to the integral from -2 to x of, what was it? Let's go look. Of f of t dt, okay. F of t dt. So like I said, take the derivative, set it equal to 0. So g prime of x, okay, that is going to be equal to, well, the derivative of an integral just cancels each other out. So this is going to be equal to f of x, yeah, so g of x or f of t, whatever, it doesn't matter, we'll say f of x. G prime of x is equal to f of x, and we want to set this equal to 0. So when is f of x equal to 0? Well, let's go look at our graph. F of x, when are you equal to 0? I see, let's use blue. F of x is equal to 0. Oh, sorry, that's hidden. Let's fix that. Okay, f of x is equal to 0 right here at -1. Right here, this point is 1/2. And where else? Oh, right here at 5. So we have points -1, 1/2, and 5. And we also need to test our endpoints when we're doing max and min values. So we're also going to test -2. These are all our points where our g prime is equal to 0. We're going to plug these now into g of x. So let's go do that. G of x. Okay, so g of x, we want this in purple. Oh, these hidden layers. G of x, well, we want, okay, g of -2, we'll do first. G of -2, we want g of -1, g of 1/2, yeah, that's what it was, and g of 5. And we want to see which of these is the greatest value, right? We're looking for our maximum value. So to do this, g, let's go look back at our graph. Okay, so g is equal to the integral of f of t from -2 to any of our points. So from -2 to -2, we're not moving anywhere, so that area is going to be equal to 0, right? Our next point is from -2 to 1, right? And we have this little triangle right here that denotes that area, and that's equal to 1/2, right? That's the area of that triangle. If we go to where we want to go to positive 1/2, when x is equal to positive 1/2, well then we are going to only have the area of this triangle here. Let's use different colors. Let's use a pink. Only this triangle, because everything else over here cancels each other out. Now the area of that triangle is equal to negative 1/4. So that's not a maximum value already, because we know that from -2 to -1, the area is 1/2. So far we have what's it called? That's going to be where our maximum value is located. Well, that's what the absolute maximum value is. Now, okay, what's the last one we have to check? G of 5. So that would be the area underneath the curve from -2 to 5. Well, we found that earlier, remember? We found that the area from -2 to 5 is actually equal to this right here, 11 minus 9 pi over 4. And that is greater than 1/2. So that is going to be our absolute maximum value of G on the interval. So let's write that down in purple, since all of our answers are in purple. Our maximum value is 11 minus 9 pi over 4. So that one may have been a little bit confusing. I mean, all of these may be a little bit confusing, but I'm going to just review what we did for that. We took the derivative of g of x, set it equal to 0, found our critical points, which were at -1, 1/2, 5, and then we tested our other endpoint, -2. We plugged those into our original function right here, g of x, and we just looked at what the maximum value was. And that was 11 minus 9 pi over 4. Now, other questions might say, find at what point is the absolute maximum value. That's not what we're doing here. We were just finding the actual value, which is 11 minus 9 pi over 4. Now, we only have part 3 left. Ooh, it's a limit. Isn't that fun? Find the limit of 10 to the x minus 3f prime of x over f of x minus the arctangent of x as x approaches 1. Okay, this is going to be one where we're going to go back and forth between screens. So 10 to the x minus 3 times f prime of x. 10 to the x minus 3 f prime of x. 10 to the x minus 3 f prime of x. All over, let's go back and look. F of x minus arctangent of x. F of x minus the arctan of x. Oh boy, I can hear everybody who didn't pay attention during pre-calc tapping out right now. And we're doing the limit as x approaches 1. Okay, so this is 1. This is a limit where we're just going to substitute, since we have a continuous function, we can just substitute our value x into our limit, right? So let's evaluate this. 10 to the first power minus 3 times f prime of 1, f of 1, minus the arctangent of 1. I can't wait for that part. So 10 to the 1, what does that equal to? Congratulations if you knew that the answer was 10. Minus 3 times f prime of 1. Now f prime, what does that mean? That means the derivative of f, which means the slope of f at 1, right? So we have a ton of colors here. So what is the slope at our point? Oh my god, these hidden layers. What is the slope at our point 1? Well, the slope at 1, it looks like our line is going up 2 over 1, up 2 over 1. So it looks like that's going to be equal to 2. All right, let's put that in here. So 10 minus 3 times 2, that's going to be equal to 6. So 10 minus 6. F of 1. All right, what is f of 1 equal to? F of 1, well, that looks like hidden layers. I apologize for these hidden layers. F of 1 is going to be equal to 1 as well. So let's go back there. So this is equal to 1 minus an arctangent of 1. How many people know what this is? Arctangent of 1, if you don't know, is equal to pi over 4. That's just something you should have known from pre-calc. This is unit circle stuff. If you don't know the unit circle, go learn it right now. It is very nice. And let's evaluate this. This is going to be equal to 4 over 1 minus pi over 4. Now that's a real number. We're not dividing by 0. We don't have any issues. And so that is going to be our answer. 4 over 1 minus, here, let's write this is equal to 4 over 1 minus the pi over 4. And with that, we have solved one question out of the 6 free response questions you will get on your AP exam. Now, obviously, that took longer than it should have because I was explaining my thought processes and everything. But hopefully watching this video has shown you how to tackle these problems, how to translate what they're asking you, and hopefully just do better on your next free response question on your exam. If you made it to the end of this video, thank you. I really appreciate it. I know this was a long one, and I hope you learned something.